Hi everyone, my name is Mark Vinciguerra. I'm a Specialist Solutions Architect at AWS, and today we'll be deploying Anyscale on HyperPod. We'll be using this repo, AWS Do-Ray, in the AWS Samples repository. It comes with some pretty intuitive scripts to get it going, but first let's look at our HyperPod cluster that we're deploying Anyscale on. We use an autoscaler being Karpenter, and if you look at our instances, we have right now spun up two head group CPU instances. We do have a worker group consisting of the GPU nodes, but as of right now, there's a current count of 0 instances. So if we were to look at the autoscaling configuration, we could look at our node pool YAML. And basically what this is saying is it will create G5 8x large ML instances, and it requires these nodes to have the GPU capabilities. There's some more rules that you can put in, which are stated in our autoscaling documentation. But yeah, today's goal is we are going to be deploying Anyscale and running a job, and we'll see that it'll automatically scale out the instances. So when we run Anyscale, we want to make sure we have our environment variables set up properly for this repo. We have the Anyscale cloud name and your HyperPod cluster name. So the first step is we could just run deploy requirements. What this does, it creates an Anyscale namespace and installs required dependencies like the Anyscale CLI, performs an Anyscale login, and adds and updates the Anyscale Helm charts. It also sets up networking by installing the NGINX ingress controller. Now at this point, we can run the create EFS script. What it does, it's going to retrieve subnet ID, your VPC ID, security group ID of your HyperPod cluster, and then create an Elastic file system. It'll be encrypted and tagged with a name that you specify in your environment variables. It's also going to be creating a mount target in the specified subnet. Now we can run the register cloud script, and what this is doing is it's going to fetch the S3 bucket name that's associated with your HyperPod cluster and making sure that the Anyscale role has read, write, listing, and deleting permissions. Then we assign this role, this policy to the role, and then we're going to be registering the cloud with Anyscale. So we set up a cloud configuration with AWS as the provider. We input our AWS region. We specify Kubernetes as the compute stack. We also specify an availability zone, the IAM role for the Anyscale operator, and the S3 bucket for storage, as well as the EFS for storage. And the final script that we can run is deploy Anyscale. What this is doing is it's using Helm to install / upgrade the Anyscale operator and configure this operator with the registered cloud that we deployed in the last step. So now we can look at our Anyscale console, and we could see our newly provisioned autoscale demo cloud that we created in the Anyscale console. Now that we have everything up and ready, we can now submit a job. We're going to be submitting a distributed training PyTorch job. It's an MNIST example. To do this first, we have to create a compute config. If we were to look at our compute config, basically what we're saying is we want 1 head node and 4 GPU worker nodes with 1 GPU each. And now we can run create compute config, which will configure our compute config in the Anyscale console. So we can copy and paste this here and see it in the console. And now our final step is to submit the job. So as a reminder, we have 0 GPU instances spun up right now. If we look at our job config, we are using the Anyscale managed container with our compute config, and we're passing in some of our credentials with the Python code. So now we can submit our job. And if we wait a moment, we'll eventually be able to see the pods get spun up in the Anyscale namespace. Right now we still just have the Anyscale operator. But we can go to jobs in the Anyscale console and we could see the job pending. Now at this point, it spun up the head pod. And it is pending because there is no GPU node for it to land on. We could describe the pod and see that Karpenter is saying it could be scheduled on this node claim that we created. So we can look back in our console, in our HyperPod console, and see that the autoscaling kicked in and it's spinning up a G5 8x large instance. This takes a few minutes, so I sped it up, skipped some time, and now at this point we have our head pod and worker pods spun up. We could see it was scaling before and it successfully went through the code. We see that the training is done. Through our logs. And yeah, it started with 0 GPU instances. We submit the code, it spins up the pods, they're in pending state waiting for the instances or nodes to get spun up. And then once they're spun, the job commences. And now that the job is successful, the pods will soon terminate. They'll be in completed state and terminate. And then we could see that once this happens, it will automatically scale our HyperPod nodes back down. So the pods are starting to terminate. I'll refresh our HyperPod page and we see the instances are starting to get shut down. This takes a second. I'll fast forward. And now our GPU instances are back down to 0. So that's it for the demo on Anyscale on HyperPod with autoscaling. This is all in the AWS Do repo, so please feel free to give it a try yourself, and thank you all for watching.